Welcome to this 5-minute guide on understanding Hilt annotations in Android development. Hilt is a powerful dependency injection library that simplifies the process of managing dependencies in your Android projects. Built on top of Dagger 2, Hilt reduces boilerplate code and makes your applications more maintainable and testable. In this video, we'll walk through the essential Hilt annotations, their roles, and practical examples to help you integrate Hilt smoothly into your workflow. Whether you're new to dependency injection or looking to refine your skills, this guide will provide clear explanations and actionable insights. Let's dive in and explore how Hilt can transform your Android development experience. Dependency injection is a design pattern that allows you to provide objects that a class depends on, rather than having the class create them itself. This approach leads to cleaner, more modular code and makes testing easier. In Android development, dependency injection helps manage complex object graphs and ensures that components receive the dependencies they need. Hilt streamlines this process, making it accessible even for beginners. By using annotations, Hilt automates the setup and management of dependencies, freeing you from manual configuration. Understanding this concept is key to leveraging Hilt effectively in your projects. Hilt is built upon Dagger 2, a well-established dependency injection framework. While Dagger 2 offers robust features, it can be complex and requires significant boilerplate code. Hilt addresses these challenges by providing a simpler API and automating much of the setup. With Hilt, you can focus on building your app without worrying about intricate dependency graphs. It's designed specifically for Android, integrating seamlessly with the platform's architecture components. Understanding the relationship between Hilt and Dagger 2, you'll appreciate how Hilt enhances productivity and code quality in modern Android development. Hilt annotations are special markers that instruct the Hilt library on how to handle dependency injection in your Android project. These annotations are applied to classes, methods, and fields to define how dependencies are provided and managed. Some of the most common Hilt annotations include at Hilt Android app, at Android entry point, at inject, at module, at install in, at binds, at provides, at qualifier, at entry point, and at assisted inject. Each annotation serves a distinct purpose, from initializing the dependency injection framework to specifying how objects are created and injected. In the following scenes, we'll break down each annotation and show you how to use them effectively. At Hilt Android app annotation is applied to the application class of your app. This annotation triggers Hilt to generate a base class that initializes the dependency injection framework for your application. By adding at Hilt Android app, you ensure that Hilt is set up correctly and ready to manage dependencies throughout your app. Remember to register your application class in the Android manifest XML file to complete the initialization. This setup is crucial for enabling Hilt's features and ensuring smooth dependency injection from the start. Let's look at a sample application class using the at Hilt Android app annotation. By extending the application class and annotating it, you allow Hilt to set up the dependency injection framework. This class acts as the entry point for Hilt, ensuring that all dependencies are managed from the top level of your app. Proper setup here is essential for leveraging Hilt's capabilities throughout your project. To initialize Hilt, you must add your application class to the Android manifest XML file. This step ensures that Hilt is properly integrated and ready to manage dependencies. The manifest entry specifies the class name and other attributes, completing the setup. Without this configuration, Hilt cannot function as intended, so always double-check your manifest when starting a new project. At Android entry point annotation is used to inject dependencies into Android component classes like activities, fragments, and services. By annotating a component with an Android entry point, Hilt generates the necessary code to handle dependency injection for that component. It's important to note that if you annotate a fragment, you must also annotate any activity that uses that fragment. This ensures that dependencies are properly managed across the component hierarchy. To inject dependencies into view models, use the at Hilt view model annotation. This annotation allows Hilt to manage the creation and injection of dependencies for your view model classes. By combining at Android entry point and at Hilt view model, you can seamlessly inject dependencies into both activities and view models, streamlining your architecture and improving testability. At inject annotation is a general-purpose marker used to indicate fields, methods, or constructors that should be injected with their dependencies. There are two main ways to inject objects: constructor injection and field injection. Constructor injection is preferred, as it ensures dependencies are provided during object creation and promotes better testability. Field injection is less recommended and should be used only when necessary. Constructor injection involves annotating the constructor of a class with at inject. This approach ensures that all required dependencies are provided when the object is created. It's the recommended method for injecting dependencies in Hilt, as it leads to more maintainable and testable code. By using constructor injection, you make your classes easier to work with and less prone to errors. Field injection is another way to inject dependencies, where fields are annotated with @inject. Hilt automatically provides instances for these fields when creating the class. However, fields injected by Hilt cannot be private, and attempting to inject private fields results in compilation errors. While field injection can be useful, constructor injection remains the best practice for most scenarios. Working with Hilt, constructor injection is the recommended approach. It ensures that dependencies are provided during object creation, promoting better testability and maintainability. Avoid using field or method injection unless absolutely necessary. Following these best practices will help you build robust and scalable Android applications. Yet module annotation is used to define module classes in Hilt. Modules provide instructions to the dependency injection framework on how to create and provide instances of dependencies. This is especially useful when a class cannot be instantiated directly, such as interfaces or third-party classes. By defining modules, you give Hilt the information it needs to manage complex dependencies. @install in annotation specifies the component in which a module should be installed. It defines the scope and visibility of the module's dependencies. For example, using singleton component means the instances created in the module live as long as the application does. You can also use activity component or fragment component for activity or fragment scoped instances. This flexibility allows you to manage lifecycles and scopes efficiently. Let's examine a module example using @module and @install in. By defining an object or abstract class and annotating it, you instruct Hilt on how to provide dependencies. This setup is essential for injecting interfaces, third-party classes, or builder pattern classes. Proper module configuration ensures that Hilt can manage your dependencies efficiently and reliably. Yet binds annotation tells Hilt which implementation to use when providing an instance of an interface. In contrast, @provides is responsible for creating and returning instances of dependencies. Using @provides gives you more control over how dependencies are created and allows for customization. Understanding the difference between @binds and @provides is key to managing interfaces and complex objects in Hilt. Injecting interface instances, use @binds in your module. This annotation allows you to specify which implementation should be used for a given interface. By defining abstract methods and annotating them with @binds, you make interfaces injectable and flexible. This approach is particularly useful for testing and swapping implementations without changing your codebase. To inject instances of classes, use @provides in your module. This annotation allows you to define functions that create and return instances of dependencies. You can customize initialization and configuration, making @provides ideal for complex objects like retrofit builders. By using @provides, you gain fine-grained control over how dependencies are managed in your app. Common use case for @provides is injecting retrofit instances. By defining a module with @provides, you can set up retrofit with custom configurations, such as logging interceptors and client settings. This approach ensures that your networking layer is properly managed and integrated with Hilt, making it easier to maintain and test. Yet qualifier annotation is used when you need multiple instances of a class with different implementations. Qualifiers help Hilt distinguish between bindings that have the same type but different behaviors. By creating custom qualifier annotations, you can specify which implementation to inject, making your code more flexible and adaptable. Consider an interface called LoggerSource with 2 implementations, and Database Logger. By defining custom qualifier annotations for each implementation, you can inject the desired logger into your components. This technique is valuable for scenarios where different behaviors are needed, such as logging to memory or a database. Your module, define abstract methods for each implementation and annotate them with the appropriate qualifier. This setup allows Hilt to inject the correct instance based on the qualifier specified. When injecting the interface in your activity or fragment, use the qualifier annotation to select the desired implementation. This approach ensures precise control over dependency injection. Scope annotations define the lifecycle of injected objects. By default, all bindings in Hilt are unscoped, meaning a new instance is created each time a binding is injected. To maintain the same instance throughout your application or activity, add scope annotations. Different components have different scopes, and scoping can be costly, so use it judiciously to avoid memory issues. Scoping a binding to a component keeps the provided object in memory until the component is destroyed. While this can be useful for maintaining state, it also increases memory usage. Minimize the use of scoped bindings in your application to ensure efficient resource management. Always consider the life cycle of your components when applying scopes. Yet entry point annotation is used for injecting dependencies into non-Android classes, such as adapters or content providers. By defining an interface annotated with at entry point, you can access dependencies without using at Android entry point on an Android component. This technique expands Hilt's capabilities and allows for more flexible dependency management. Access dependencies provided by an entry point, use entry point accessors. This utility allows you to retrieve instances from the entry point interface, making it possible to inject dependencies into classes that aren't Android components. By passing the appropriate context or component, you can obtain the required dependencies and integrate them into your workflow. Let's look at a notification builder class that requires dependencies on products DAO and notification utils. By creating an interface with an entry point and initializing dependencies using entry point accessors, you can inject these dependencies into the notification builder. This approach demonstrates how to manage dependencies in non-Android classes using Hilt. You create an at entry point interface. It acts as a way to access dependencies within a particular component scope. The parameter you pass to entry point accessors, from X, should be an instance of that component or an object annotated with that Android entry point. This setup allows for precise and flexible dependency injection, even outside standard Android components. At-assisted inject annotation is used when some parameters need to be provided at runtime. This is useful for cases where certain dependencies are determined dynamically, such as a user ID or query string. By annotating the constructor with at-assisted, inject and marking runtime parameters with at-assisted, you enable Hilt to handle both static and dynamic dependencies. Consider a main view model class that requires a user ID at runtime. By using at-assisted inject for the constructor and at-assisted for the parameter, you allow Hilt to inject other dependencies while you provide the user ID manually. This technique is ideal for scenarios where some dependencies are not known until the object is created. To inject your viewModel class into an activity or fragment, create a factory interface annotated with at-assisted factory. This interface defines a function that returns an instance of your viewModel and accepts runtime parameters. By using the factory, you ensure that Hilt can manage assisted injection and provide the necessary dependencies. Inside your viewModel class, define the factory interface and annotate it with at-assisted factory. The factory's create function accepts only the arguments that need to be provided at runtime. This setup allows Hilt to handle the rest of the dependencies automatically, streamlining the injection process and making your code more flexible. Use your viewModel class inside an activity or fragment. Leverage the factory created with at-assisted factory. This approach ensures that runtime parameters are provided correctly and all other dependencies are managed by Hilt. By integrating assisted injection, you make your viewModels adaptable to dynamic data and scenarios. You've covered the essential Hilt annotations, including at Hilt Android app, at Android entry point, at inject, at module, at install in, at binds, at provides, at qualifier, at entry point, and at assisted inject. Each annotation plays a unique role in managing dependencies and streamlining your Android development process. By mastering these annotations, you can build scalable, maintainable, and testable applications with ease. Hilt offers numerous benefits, including reduced boilerplate code, improved testability, and seamless integration with Android architecture components. By automating dependency injection, Hilt allows you to focus on building features rather than managing complex object graphs. Its clear and concise API makes it accessible for developers of all skill levels. While Hilt simplifies dependency injection, there are common pitfalls to watch out for. Forgetting to annotate components, misconfiguring modules, or incorrectly scoping bindings can lead to errors. Always double-check your annotations and module setups. Refer to Hilt's documentation and best practices to avoid issues and ensure smooth integration. Hilt makes testing easier by allowing you to inject mock dependencies and manage test-specific modules. By leveraging Hilt's annotations, you can create isolated test environments and ensure your components behave as expected. This capability is invaluable for maintaining high-quality code and catching bugs early in development. If you're working on an existing Android project, integrating Hilt can be straightforward. Start by adding the necessary dependencies, annotating your application class, and gradually refactoring components to use Hilt annotations. Take it step by step, ensuring each part of your app is properly configured before moving on. This approach minimizes disruptions and ensures a smooth transition. Hilt is becoming the standard for dependency injection in modern Android development. Its integration with Jetpack components and support for advanced features make it a valuable tool for building scalable apps. By adopting Hilt, you position yourself at the forefront of Android best practices and ensure your projects are future-proof. Deepen your understanding of Hilt and dependency injection. Explore resources like official documentation, community articles, and sample projects. Platforms such as Medium, pro Android dev, and Google developer experts offer valuable insights and tutorials. Stay updated with the latest posts and recommendations to enhance your skills and stay ahead in Android development. Engage with the Android developer community to learn from professionals and Google developer experts. Sharing experiences, asking questions, and participating in discussions can help you solve challenges and discover new techniques. The community is a rich source of knowledge and support for mastering Hilt and other Android tools. Understanding Hilt annotations and dependency injection is valuable for Android interviews. Review cheat sheets, common pitfalls, and best practices to prepare for technical questions. Demonstrating your knowledge of Hilt can set you apart and showcase your expertise in modern Android development. As Android evolves, dependency injection frameworks like Hilt will continue to play a crucial role. Staying updated with new features and improvements ensures your projects remain efficient and maintainable. Embrace Hilt and other modern tools to keep your skills relevant and your apps competitive. Congratulations on completing this guide to Hilt annotations. You now have a solid understanding of how to use Hilt for dependency injection in Android projects. Apply these concepts to your own apps, experiment with different annotations, and continue learning through community resources. Happy coding, and may your Android projects be scalable, maintainable, and efficient.